Good afternoon, everybody. Today we're going to talk about the cross product. So I will probably make more than one video, but let's start and see how it goes. All right, so the objectives of my lesson are going to be to teach you how to find the cross product of two vectors in space, and then how to use the cross product to find area and volume. All right. So the cross product is used in many different areas, things like engineering, geometry. The definition is that the cross product can be used, for example, if I have vector A and I'm cross product with vector B, I'm finding a vector that is orthogonal to both vector A and vector B. So this is what the cross product does. If you want to find a vector that's orthogonal to both A and B, if you do the cross product, the result will be that vector. All right, so let's start with how to do the cross product, and then we'll talk about how to apply it to area and volume. All right, so in order to do the cross product, the first thing we need to remember is how to do a determinant. All right, now not everybody does determinants. So let's make up a very small determinant. I have A, B, C, and D. I'm going to change color so you can see it. Basically, what I did when I started learning determinants was I went from D and I drew an arrow straight up, and I went from C and drew an arrow straight up. All right, and what I did was I multiplied those two numbers. So this would equal AD minus CB. So if we hadn't, I'm going to do a quick example. I have 2, 1, -6, and 4. And I'll change colors again. So I'll put my arrow straight up, put my arrow straight up. 2, so this equals 2 times 4. And then again, I'm subtracting those two numbers, so I'm going to subtract again. Subtracted from 1 times -6. And when we do 2 times 4, we get 8 minus -6 equals, of course, positive 14. So that's the basic idea of determinants. Now I'm going to give you one so you can try it. Here it is. So here is my example. If you have this determinant, 2, 4, pause the video and see what you can do. All right, hopefully you paused the video and you did your arrows. If you didn't, that's okay. Just helps me remember what times what. So I have 2 times -1. Then I'm subtracting that from 4 times 3. 2 times -1 is -2. And then I'm subtracting that from 12, so I wind up with -14. I'll give you another one. Here's my next example. 4, 0, -6, and 3. Why don't you pause the video and try this one as well. All right, so let's say you're becoming an expert and you realize that 4 times 4 times 3, and then the key is that this negative is not your minus. You have minus -6 times 0. So 4 times 3 is 12, minus 0 is just indeed 12. All right, if you have questions on determinants, I would definitely encourage you coming by my office hours. If you feel like you're comfortable and ready to go, why don't we try one or two? So let's just try knocking out a couple of cross products and see how far we get. So if I have vector u equals I minus 2j plus k, and I have vector v equals 3i plus j minus 2k, find each cross product. Now the cross product is denoted as follows. So for my first one, I'm going to do u, and this x is now cross product. If you have two vectors on either side of an x, that is cross product. It's not traditional multiplication. All right. So my second one is going to be v cross u. And then my third one is going to be v cross v. All right. So why don't you guys pause the video, try any one of these three, and we'll talk about the answers on the other side. All right, so let's do u cross v. So we'll do the answers in another color. So for A, we're going to create our determinant. Now, our first row is going to be ijk. Our second row is going to be the coefficients for each of our vectors. So for the second row, it'll be vector u. So it'll be 1, -2, and 1. And then 3, 1, 2, -2, which is vector v. All right, so now we are going to separate this into our determinants. All right, so we start by covering up the I column, and the determinant that is left is -2, 1, 1, -2. And I multiply that times my coefficient of I, which is the column that we covered up. I'm going to now, the sign in front of my determinant is positive. There's no sign there, so we assume it's positive. So our signs are going to flip-flop. So it's going to be positive, the next one's going to be negative, the next one's going to be positive. If we had a fourth term, that determinant would be negative. So now I'm going to go to the J column. I'm going to cover up the J column and write out my determinant, which is 1, 3, 1, -2, times my J, which is the column that I covered up. And then again, the signs are going to switch, so I'm going to add that to cover up my K column, and my determinant is 1, -2, 3, 1, times K. So now that I have my three determinants all set up, I want you to pause the video. I want you to work out the determinants, and I'm going to give you the answer on the other side. All right, I hope you work out your determinants correctly. I am going to just give you the answer at this point because it is multiplying and adding. So my final answer should be 3i plus 5j plus 7k. If you did not get that answer, I want you to go back in the video, take a look at how to do determinants, and try again. But let's move on to the next one. Let's move on to B. Now B, if you'll remember, was vector v cross u, which basically means I'm just reversing the order. So let's see how this affects our answer. So I'm going to set up my three-row determinant. My first row is I, j, and k. And then I'm going to reverse the vectors. So I'm going to have 3, 1, -2, and 1, -2, and 1. Let's set this up together. I'm going to make you do it on your own. All right, so we're going to set it up together. My first determinant, I'm going to cover up the I column, and I'm going to get the determinant. So the numbers that are left are 1, -2, -2, and 1. And that's, again, times my coefficient, which is the value in the top row, which is I. And now my sign's going to switch. So minus, cover up my J column. And my determinant is 3, -2, 1, 1, times the value in the top of that column, which is J, plus cover up my K column, and my determinant is going to be 3, 1, 1, -2 times that top value, which is K. All right, so the determinants are now set up. Ask you to pause the video. Why don't you work out the result, and I'll give you the answer on the other side. All right, so hopefully you worked out the result, and I'm going to give you your final answer. Your final answer is going to be -3i minus 5j minus 7k. Again, if you did not get that answer, go back and check your work. If you're unsure if you did your determinants correctly, go back and take a look at the quick review that we did. All right. Now, for the last one was V cross V, right? So C was V cross V. And let's set up the I, J, K, my rows and columns. So I have 3, 1, 2, 3, 1, 2. Now I'm going to ask you to set this one up. Separate it out into your determinants, do that extra row of work, all right, and then do the result. So give it a try, pause the video. I'll give you the final answer only on the other side. All right, hopefully you were able to set it up and do the work. Final answer wound up to be 0, so any vector cross itself looks like it's going to be 0, and that is indeed one of our properties. All right, so let's list a couple of properties. So I have properties of the cross product. So let's let U, B, and W be vectors in space. All right, so let U and B be vectors in space. And what did we find from the last problem? That if we do U cross V, that equals the negative of V cross U. And again, these are not anything that you're going to use specifically, but they're handy to know to maybe confirm that your answers are indeed correct. We're going to do a few more. Our second property says U, cross V plus W, right, equals U cross V plus U cross W. The third, C is our scalar, times U cross V equals C times vector U cross V, which equals U cross C times vector V. Our fourth property says u cross 0 equals 0, cross u, which equals 0. So either way you do that, that equals 0. If I have u cross u, it's going to equal 0. We saw that from the practice problem we had. And the last one says, if I have u dot v cross w, it's going to equal u cross v dot w. Again, these properties aren't necessarily something you need to memorize. However, it is something that if you happen to know them, they could be really helpful. All right, so let's do an example. So let's say I had these two vectors. So if A equals and B equals, now those pointy brackets mean vector. Then find two vectors orthogonal to both. All right. So what you'll notice in this question is that I've eliminated the words cross product. And basically what I've said is find two vectors orthogonal to both A and B. So the hard part of this question is that you're going to need to know that you need to do the cross product. All right, so why don't you get started in setting up the problem, pause the video, and I will pick it up with you on the back end. All right, so hopefully you've set up this as A cross B, and we're going to say that equals, and now let's set up our determinants. So I have I, J, and K, and then if it's A cross B, A is going to be the first that I put down 1, 3, 4, and then B is going to be the second at 2, 7, -5. All right. And now we want to break these down into the smaller determinants. So I cover up my I column, and my determinant winds up being 3, 4, 7, -5. Oops, excuse me. I, and it goes positive, then negative. Now we're going to cover up the J column, and I have 1, 4, 2, -5, right? J, and then positive, negative, positive. And I'm covering up the K column, and I get 1, 3, 2, 7, K. So as long as your setup looks like this, you should be fine. So why don't you do the algebra, and we'll talk about the answer on the back end. Pause the video, do the algebra, and I'll be back with you in a minute. All right, so hopefully you did the algebra okay. Your answer should read 43I plus 13J plus K. This is your vector that's orthogonal to both. Now let's look up at the original question. It said find two vectors orthogonal to both. So if I were to take this vector and get a parallel vector, it should still be orthogonal to both A and B. So how I get a vector parallel to this one? Simply a scalar multiple. So I'm going to do a very easy scalar multiple, multiply times 2. So I get 86I plus 26J plus 2K. And here are two vectors orthogonal to both. All right. You guys want to try another one? I'm so glad the answer is yes. All right, so I'm going to give you this one. It's going to be very straightforward. All right, so vector A is -1, 1, -1, and vector B is 0, 3, 4. All right, so I want two vectors, same question. Orthogonal. Actually, you know what? Let's change the question. I want a unit vector orthogonal to both A and B. All right, so I'm changing the question a little bit. It's going to be along the same strategy. Find a unit vector, that's the only change, orthogonal to both A and B. So your strategy is going to start with A cross B. So why don't you pause the video, do A cross B, then we'll come on back and we'll talk about how to turn it into a unit vector again. Pause the video and I'll see you on the back end. All right, so with A cross B, we want to start with our 3x3 determinant. I've got I, J, K, -1, 1, -1. There's vector A. 0, 3, 4. There's vector B. All right, now we're going to break this down into our smaller determinants. So I cover up the I column, and I get 1, -1, 3, 4, I, and that's positive. So then I put a minus, and I get -1, -1, 0, 4, because I covered up the J column. That's times J. And then I'm going to add, because it was negative, so we change the sign to plus. Cover up the K column, and I get -1, 1, 0, 3 times K. At this point, pause the video, let's do the algebra, and I'll give you the answer on the back end. All right. So hopefully you pause the video and you're going to get the answer is going to be 7i plus 4j minus 3k. If you were asked for a second vector, you could just say I can do b cross a, and in that case, you would realize that all the signs would just change, so you'd have -7i minus 4j plus 3k, and that was one of the properties that we talked about earlier. All right, so now we have to turn it into a unit vector. So the question is, how do we do that? What's the first thing we need? First thing we need is our magnitude, all right? So I want the magnitude of A cross B. So why don't you pause the video for a minute and we'll get that magnitude and I'll see you on the back end. All right, so we're going to take our components and we got to square them, add them, square root them. So there's my square root. 7 squared is 49 plus 16 plus 9. which equals the square root of 74. And then we're going to simply take that and we're going to do 1 over the square root of 74. And it's going to be times 7i plus 4j minus 3k. The original question only asked for one unit vector orthogonal to both. And there you go. All right, why don't you pause the video, think about it, and when you're ready, come on back. All right. So now the last thing we're going to do is we're going to talk about area and volume. All right, so if we had a parallelogram where vector v and vector u were adjacent sides, theta was right in the middle, the area of our parallelogram would be the equal to the magnitude of u cross v, as long as u and v were vectors of adjacent sides. If we were to do area of a triangle, all right, and u and v were adjacent sides, all it would do would be to cut the parallelogram in half. So I do 1/2 the magnitude of vector u cross vector v. All right, so these you can use to your advantage. All right, so let's do one of these. So area of triangle PQR P is 1, -1, 2. Q is 2, 3, 1. And R is -2, 3, 4. So I have points in space, but I don't have vectors. So how are we going to get our vectors? Well, first thing we need to do is we need vector PQ. And we need its adjacent side, which would be vector PR. All right, so why don't you go get those vectors, and I will see you on the back end. All right, so hopefully you received vector PQ and got 1 for -1 and vector PR as -3 for 2. All right, if you didn't, again, go back and see how you take points in space and turn them into vectors. But now we got to find the cross product. These are adjacent sides. So we need the cross product. We need PR cross PQ or PQ cross PR. Doesn't matter which one. I'm going to do PQ cross PR. You could have done it the either way. it's not a problem. All right, so we're going to start by making our matrix, our 3 by 3. So I have 1, I, j, and k. 1, 4, negative 1, negative 3, 4, and 2. All right. And next, we're going to break this down into our smaller determinants. So why don't you pause the video, do that, and I'll give you the answer on the back end. All right, so we cover up our I column, and we wind up with a determinant of 4, negative 1, 4, and 2. I. We then subtract 1, negative 1, negative 3, 2. J. Plus 1, 4, negative 3, 4. K. And when you do the determinants, you wind up with an answer of 12i plus j plus 16k, which would be orthogonal to both. All right, so in an effort to finish this problem, we are now going to need the magnitude of this vector. So why don't you hit pause on the video and start working on the magnitude. I'll catch you on the back end. All right, so let's take a look at that magnitude. So I square them, add them, square root them. So there's my square root, and 12 squared is 144, 1 squared is 1, and 16 squared is 256. So it winds up being the square root of 401. Being that this is a triangle, I have to times it by a half. So I would say the square root of 401 divided by 2 is the area of triangle PQR. So why don't you go ahead and check your work, and we'll move on whenever you're ready. All right, so there's a parallelogram. And however, most of the shapes that we're going to make are going to be taken into 3 dimensions. So if we took a parallelogram, let's say I'm not the greatest at drawing this, but I'll give it my best shot. And then I wound up taking it into 3 dimensions. Like I said, not the greatest. Let's see. A little bit better. This is called a parallelepiped. All right. And we can use, again, the same dot. Well, now it's a dot and cross product, but we can get the volume of a parallelepiped by saying the absolute value of vector A dot, B cross C and we have the absolute value around there because we are doing volume, and volume can't be negative. So let's take this parallelepiped. Let's do a quick example. This will be our last example of the video. We will find the volume of the parallelepiped with P at 0, 0, 0, Q at 3, negative 2, 1 are at 1, 2, 2, and S at 1, 1, 4. Now we need 4 points because, again, we're not only doing a parallelogram, but it is a 3-dimensional parallelogram. So we need 3 adjacent sides. So my first step is going to be, I want vector PQ. I want vector PR. And I want vector PS. If I get vector PQ, PR, and PS, then I will have 3 adjacent sides. So why don't you pause the video and get those vectors, and I'll see you in a minute. All right, so vector PQ, let's take a look, is 3, negative 2, 1. Vector PR, 1, 2, 2. And vector PS is 1, 1, 4. If you do not get any of those vectors, again, double check your work. All right, so this in the formula would be, let's say, vector A. This would be vector B. This would be vector C. So, of course, if our volume equals A dot B cross C, right, the first thing we need to do is B cross C, and then we can do A dot. I'm going to show you a little bit of a shortcut. All right, we can do it with a 3x3 matrix because as long as we put our first vector on top. So I can say volume equals 3, negative 2, 1, 1, 2, 2, and 1, 1, 4. This would be the equivalent of doing both of those operations just all at once. All right, so you're going to do the vector exactly the same. We're going to cover up the first column and the first row, and I wind up with 2, 2, 1, 4. All right, and instead of putting an I, right, there's a 3 there, so I'm going to put the 3. I'm just going to put it in front. Makes it look better to me, right? And then that's subtracted. Now the number up top is a negative 2, so I have negative 2 in front. And then I'm going to cover up that middle column, and I get 1, 2, 1, 4. And then lastly, I'm going to add, and the 1 is there in place of the K. And I have 1, 2, 1, 1. Why don't you guys pause the video? Let's do some algebra and tell me what the volume is. All right, hopefully the algebra was not a problem. And you got a volume of 21. Again, this is just one way to do it. You could have done B cross C first, gotten that vector, and then A dot that vector you had gotten. It would have been the same exact answer. Actually, why don't you, when the video ends, do B cross C first, then you do A dot that vector, just do it in 2 pieces, and confirm that you would have gotten the same answer either way. All right, so this concludes the cross product. Hope you guys learned a lot, and I will see you next time.